Hello guys and welcome back. So let's set up some debug messaging so that we can see what's going on, right? We're gonna go ahead and try to uh, pull the error message from those compilations. I believe there's something wrong, but we can check our code and just figure that out ourselves, but it's better to actually have some error message in case, in the future we have more complicated errors. It's hard to just read through the code and trying to understand what's going on other than having some help from the compiler. Okay, so we can maybe create a function to do that. So I'm gonna go ahead and go all the way to the top. I'm gonna create a function called void maybe std string. I just So I just need to print it out, so I probably don't need to do anything other than just have a function that's not returning the message, just get it printed out. Okay, so get shader compilation message. Okay, and then of course we need to pass in shader, right? Okay, so here we need to first of all check what's going on with a boolean, but it does not take boolean. We have to use an integer, so int result or maybe success. Okay, and then we can also have a container to get the information, so char log, and then we just have 512 maybe for the how long we need to get, and then we can then say gl get shader 5, and we're getting the shader, of course. Getting the message from the shader, we're getting the GL compilation status, right? And then we're passing our success. So basically, we're trying to get, the status first of the compilation. And if not success, right? Then something is going on. We need to pull the compilation arrow. So GL get shader info log, right? We're getting the information. Okay, and of course we need to pass in the shader, and then buffer size we have 512, right? And length is null pointer, just get 512 bits of data. Should be enough information to read, and then we just pass in our log. Okay, right? And then let's just see out that. So shader compilation arrow. Okay, and then we pass out the log, right? So that will give us the shader compilation message printed out. So I want to do that for both shaders after they're done. Okay, so that's gonna be our vertex shader first. Okay, so try run this. Right. Oh, we do have a compilation arrow already. On line 7, syntax arrow, I expecting that. You can see we're actually able to pull the compilation arrows on line 7 of our vertex shader, right? So let's take a look at that. Line 7. Oh yeah, well, we're doing vector 3. Sorry, I was probably being too fast. So this should be just a variable instead of a data type. That's clearly wrong. So I'm gonna go ahead and run this again. Right, we're still getting black triangles, but I don't see any arrow pointing out here. So I guess vertex shader is fine. We can move on to compilation arrow for the fragment shader, I guess. See if fragment shader is having any arrows. I guess not. So that means our shaders are fine. There's something wrong maybe to our program then. Let's go ahead and check that. So we have link program. Unless there's a link arrow, let's check that. Okay. So we're going to do that just on site, I guess. Maybe you can create another function just to be able to use it later, I guess. Void get shader program message. Okay. link message because they're already compiled. Okay, unsend int program. Okay. All right, then we'll do another success. Okay, and then we just do the same amount of logging buffer here, and then we do get. This time it's program IV. Okay, and then we're getting, of course, we're passing our program, and here we're gonna try to check the not compile anymore because we're already compiling. So this is gonna be a link status, right? And then the address of success. Okay, now if not success, then we need to pull that data out, right? So that's gonna be gl get program info now, info log. Okay, and then we're trying to get that from the program we passed in. So 12 bits of data, and then now bytes. That's bytes, not bits. Okay, and then our log, right? And then we see out program linking arrow and log end line. Oh, missing a column. All right, so I'm gonna try to do that. Get shader programming a link message. I'm gonna do that after, of course, here. Okay, program. Alrighty, so I'm gonna run this again. So yeah, we do have a linking arrow which is empty, right? That doesn't help at all. So something's wrong with the linking for sure. Let's check our. So linking wouldn't be a problem. We just, yeah, it doesn't take any other arguments. So maybe our attachment is wrong. Yeah, that's right. So we're passing them in the wrong order. So that should be the program first before we pass in the shader. My bad. So I'm gonna go get those things out or swapped, and that should make it work now. Okay. Alrighty. All right. Yeah, indeed. Now we don't have any arrows, and we got the color we specified here in the fragment shader. Okay. I guess next thing we can do to test is to maybe pass in some more, use some more information to change maybe the color of the triangle. We can use the position of the vertex to shift the color of the triangle so that it's kind of have a colorful layout because every vertex has a different coordinate, right? So to do that, we just need to go to the vertex shader. Let me actually drag them side by side and put this guy in here. Okay. So what we need to do is to output something. Okay. I'm going to do out vector 3 vertex location or position. Okay. Right. And then we can say, okay, vertex position will be equals to a position basically. Right. And here just symmetrically we can then do in vec3 vertex position. So that's going to read this with that, right? So now we can say final color is equals to that, and we add some offset. So that can be plus with another vector 4. In this case, we're add the vector position. Vertex position, and then with an alpha of 0, or that's not the alpha, that's just the last element, right? So the reason we need to use 0 is because that's already 1. That's going to make the matrix calculation correct in there. Actually, yeah, that's not even matrix calculation. That's actually the alpha needs to be 1 eventually, so that has to be 0, right? So we just add that offset to the color that's based on the vertex position. Okay, alrighty, let's try to run this. Right, you can see indeed we're having like a different color layout now, and this is again, it's based on the vertex position, and because they're in different positions, right, they're getting different colors. And the reason you have this gradient is because for this vertex and that vertex, they do have a specific location, right? So you can just read that. For anything in the middle, those pixels doesn't really have a vertex, right? So to make that work, what's happening is that the position is kind of like interpolated based on the two values here, right? So if it's in the middle, then that's the blend between that and that 50%, right? You can just lerp between those values, right? Alrighty. So that's it. That's gonna be our arrow handling. So we're able to handle the arrow now based on those two functions for shader compilation message and program link message. Right, that's good. So now we have kind of like a working primitive, right? Everything's working. We can draw triangles. We can change their color. We can then gradually complicate our system so that they're able to do something a little bit more fancier. All right, that's it for this video, and see you guys next time.